Our speaker today is Joel Baker, and Joel Baker is product manager at SRW. He's a University of Minnesota graduate who has learned both the science behind the chemicals and the practical skills needed to succeed with Hedberg Products. Joel was a member of our Hedberg team back in 2006 through 2008, and he was in our purchasing department. So we've known Joel a very long time, and watched him grow and learn, and he travels around the country now doing these seminars, so we're really excited to have him here. His responsibilities at SRW include research and development of new products, guiding formula improvements, and creating education materials. Joel's specialty is providing technical support and training seminars for the full line of SRW products. His practical tips have helped numerous hardscape professionals avoid the pitfalls that can be encountered in sealing, cleaning, and polymeric sand are not installed properly. So with that, we just want to welcome Joel. Thank you for being here. Thank you all for taking the time today to learn about what Joel's going to teach us. Thank you very much. Let's make sure that this works here. It does work. So we had talked briefly before we got started today about, do you guys have any questions, any concerns about polymeric sands that you'd like to review today? And you had brought up the idea of really proper installation of wide joint material. What's going to make that succeed or fail? And we'll get into that towards the end of the presentation on polymeric sands. You guys had mentioned a little bit about the different products on the market, what really separates them, and we'd be happy to get into that. And I'll name products by name, maybe not with comparisons that we're doing, but we can certainly tell you some of the benefits or the drawbacks of certain products. So, you guys have any other questions that you'd like to talk about?
This old house, they just had a job. They had some brick pavers they set, very small job, basket-weave. They brushed in the sand and they left it. They were going to leave it set by itself with rain over it. Huh. I'm not kidding you, I couldn't believe this. So they were done with the job. The show stopped. So I didn't quite get that.
At the end of this presentation, I actually have a comment because most homeowners, for whatever reason, believe that to be the case. I had a customer, a homeowner, call in, and she didn't have a problem with our product, but she had left it sit for a week because, well, the project was much bigger than she thought it would be, and as long as she didn't activate it with water, she thought that it was still going to be good. And I raised some genuine concerns about that, and that is misinformation in the market, no matter how we try to educate folks. But that is a true concern, and you're right to bring that up. So let's talk about that one first.
Well, these folks in that show they're about as top shelf as you're going to get, I think.
Nobody can be an expert in everything.
I'll tell you what, it's very good.
Yep.
Okay. But when I saw that, I didn't quite get that. So I didn't understand it, but anyway.
Let's talk about the basic concept of polymers within sand. And they're a dried glue. So the way that product is made, it's in liquid form to blend those ingredients, the monomers, together to make the polymer, the end product. They shoot it through a tunnel that shoots the liquid on the top, and this drying tunnel is 50 feet tall, and as it kind of works its way to the bottom, hot air is going up through it, drying out those polymers. And so what they have at the end is oftentimes flakes, which are then reground into a very fine powder, which we would use for polymeric sand. Those have one activation that really makes the difference between success and failure. You have one shot with polymers, so it's our job as a manufacturer up until the point of sale to keep that product as dry as possible. Because after that, it's not just the polymers that are in the mix. We have reactive technologies. We have other add mixes that are put in there to adjust pH.
that they're going to react with water once they're put in an area. And typically in our environment here, the ground has always got some level of saturation or moisture in it. If they don't get activated by full saturation, like we recommend with our instructions, you'll find that those materials react with the moisture in the air or in the ground, but there's not sufficient moisture there to cause them to swell and to kind of lock everything together. Here's an example of what our polymeric sand does. This is done last week, and the idea here is once those polymers touch everything, they touch the sides of the pavers, the sand that's around them, and as they start to dry out, they want to pull everything in and kind of hold it tight. That was very flat and level when we put the sand on it, just like this one is here. I'm not going to pass it around, it's just dried sand. But you can see that's below the level of the dish or the jar lid. Kind of pulls it down. Competitive sands don't necessarily do that, and we'll show you some samples here a little bit later. But with that one opportunity, and you leave it sit out for a week, there is a real risk that sand is not going to set up properly. It's hygroscopic is the technical term. It wants to absorb moisture any way that it can, as quickly as it can. So that's when we first start putting water on it, we want to continue adding it. Competitive products, their polymers are such that they kind of create a dome over the joints. And Alliance had a true problem with that for many years. They got around that by putting surfactants in their sand, which is like a Dawn dishwashing soap, a dried version of that. That allows the water to migrate through. It's a wetting thing, so as soon as the water hits it, it helps it to draw through. There are some problems with that. But overall in the market, what you find is that proper activation is the key failure. Because in the past, even with our old Pavermate product, you put too much water on it, well, what happens? The polymers are lighter than water, right? They lift out, they wash off, even worse, they encase the surface of the pavers, and then you're left with a joint that will not set up. Well, now, maybe you do a light misting and you don't activate those joints fully, so at best, you have a skin over the top. So proper activation is very key and critical for these applications. You can see over the last couple of years that the competition along with SRW has changed their recommendations for applications of water. In the past with ours, we would say mist it down, let it sit for 2 minutes, wet it down with kind of a showering, let it sit for another 2 minutes, and then hit it a third time to try to get that water to migrate all the way through. Well, the idea behind that waiting period is we wanted to make sure that the water wasn't flooding the surface and was allowed to soak through at a very consistent rate. Well, now with the technologies that we have, we're not worried about the polymers washing out, but in ours it's a reactive technology, so we have a limited time on how quickly we need to get that water incorporated in before the sand simply repels moisture. And that means I've designed the instructions to tell you need to get all the water down in a given area in 2 minutes. And that's pretty straightforward. You missed it. And the reason behind misting a joint is no more than creating surface tension on the surface of that sand. Because if you hit it with a showering effect when you first put it down, when you first wet it, what's going to happen? That sand is so light and fluffy, it just kind of shoots out. Just a little bit of water, the tension created by the water itself, not even the reaction of polymers, causes that joint sufficient tension so that it doesn't wash out with further application, with that showering again, wetting it down, essentially flooding those joints. So if you were to install polymeric sands, the new technologies, whether it's SRWs or anybody else's, and followed the old rule of let's wet down the whole driveway, mist it down, come back 5 minutes later, put another application on, and maybe do a third or just let it go at 2, what happens? They have some true issues in the fact that it is entirely possible that those joints could resist the absorption of water. So there are ways of getting around it, but the general rule is working in a sufficient area that you can manage in just a couple of minutes. And that's about the area of these tables here, about 200 square feet. You start at one corner, just kind of mist it down lightly, immediately go back up to that edge where you started, and shower it down, keep flooding that surface. And by doing that, we get down here at about a minute and a half, we go up for a third application for it. It's typically sufficient amount of moisture to get all the way through that joint. It's at the 5-minute mark where we start to see resistance of that absorption of moisture. A chemical reaction is occurring within the sand that prevents it from ever washing out. A chemical reaction is it's a gelling. So those polymers no longer are sticky. So they react. They, in a liquid sense, they're kind of crystallizing. And it's at this point that we don't want to scrape it out. If we do scrape it, then we affect the overall integrity of that area. If we scrape out an area at that 5-minute mark, and we go to put it back in, well, that area of sand will not have the same strength as if you simply just let it sit. Does that make sense?
So if we're gonna test the depth of the water going down, we need to do it.
Yeah. So the activation of water is a 2-minute process, 3 applications. So 200 square feet to 2 minutes, that's a fair amount. You're not going to be standing around, right? So it shouldn't slow the operation down. The competition alliance out there with the new rapid set technology sands, they're saying that they recommend 30 square feet in 30 seconds. Well, in 2 minutes, they're doing what, 120 square feet? We're doing 2 minutes square feet. So ours certainly has better square foot coverage, but the idea here is you're seeing a pattern in the industry where it's a consistent application of water without over-applying it. That's totally flooding the surface, but keeping it wet, keeping it absorbing into that first couple of minutes. Is there any questions?
When you do it off, you don't have a problem with the dust on the
Well, I'm just trying, we have a process at the end of the PowerPoint, but let's talk about a proper installation. Let's talk about what the competition says. Does everybody know what the competition is saying? And when I say the competition, I'm talking about Alliance. They're the ones that are trying to change the industry, that they've simplified the process of installing polymer sand. You sweep it on, you compact over the top of the sand that's sitting on the surface to pavers, you simply sweep it off and you activate it, right? There's a lot of steps there that they're missing that they still recommend doing that really isn't any different than a proper installation. So the first thing that we want to do is make sure that the pavers are installed properly, whether it's an existing job where we glue out the joints or it's truly a new installation. It's making sure we have a proper drainage bed underneath the pavers. 1-inch layer of sand is typically what we need there. Our sand is free to be used on concrete overlays as well as a standard installation with a compacted base material. But in both of those, we're still applying 1 inch of pre-mix sand. So we start off, those pavers have been compacted without polymer and sands in them to kind of set the heights. Everything is good there.
Right.
Yeah.
What if you're using like granite chip as opposed to sand?
For your drainage layer or your base?
For your drainage.
That is very popular out in the Northeast, out in Boston area and things like that. But believe it or not, that is not recommended by the manufacturers or ICPI. They're recommending truly just a 1-inch sand layer, mason sand, something with sufficient. And the idea here is that layer, pavers have some irregularities. And in the past, at least 3 years ago when I looked at this, they had a 1/8 variance that was acceptable on the paver. So each paver is 60 millimeters, is that right? Yeah, okay. So 60 millimeters, 80 millimeters, 3/8 inches. So 1/8 of an inch on that could mean that a 20 is an 1/8 of an inch low, and a 6x9 might be 1/8 of an inch high. That's a 1/4 inch variance between those pavers and that sand layer. Once you set all those down and you compact it, it evens out the heights as that goes across. If you have chips in there, and how it evens out the heights is the sand is allowed to go up into the joints from underneath and help settle everything out. Oftentimes, It's recommended, maybe you guys have a different pattern, but when I did a 1,400 square foot install, they said we should account for about 3/8 of an inch of settling after compaction of that sand, driving that sand up into the joints from the bottom. And it's very difficult to get that done when you have a chipped stone.
Well, it's easier to chip through the water with the stone. It's so,
Yep.
because
So-
you're trying to get as much drainage through it, at least one of the stuff. So I was just wondering in terms of really like, do you need to double your compaction, like go around for that, because it's so quick to down and you're going to chip more than.
So that's good. This is deviating a little bit from from the Z3, in that is for a flagging or a flagstone application, a natural
Well, I'm
stone.
talking dimensional stuff. We'll put that.
Yeah. But with those natural stones, you can't do the top of the compaction. Because you can't run that plate compactor over the top of it. Too much of a risk of cracking those stones. They're just too big of a surface area. And so that is one exception. For your application and with natural stones, I think the chip is probably okay. But again, the idea here is that it's a very clean material, very consistent, so that the water can migrate off of the job. If you like using that product for natural stone, the recommendation is still using the sand layer, but you might get a little bit more stability out of the chip, as long as you're getting stability on the stone on top before you activate the sand. A key thing with natural stone is once you sweep the sand in and you compact around, walk across each one of those stones, and if you notice that there's any tilting or twisting on those, go back around that stone and pack the polymeric sand in around it. And whether you're using a rubber mallet on the edge or whether you're using the stake process that I told you, a blunt stake that's flat on one end and pointy on the other. If you're standing up, I have that back, so it works really well for me. But 42-inch stake, you can do the flat end, get the big areas, the open areas between the stones, and then around the stones, take the pointed end and drive it around. So if you're standing, stand off the stone, tap it, walk on it. Feel that it's stable. If those stones are not stable before you activate it with polymeric sand, it's not automatically going to make that area solid. Because there's nothing really supporting that stone then. And that sand at base layer is really necessary. Yeah, absolutely. So, as you can tell, I keep I lost track of where we were.
That's all the job shows.
You're talking about the hydrating, the new process and all that for compaction.
You have the issue of dust. We're going with yes and no. So let's finish up the basic installation of a polymeric sand. How we recommend it. We recommend a traditional means for a paver sand, and that is to, once the pavers are compacted from installation of the pavers, sweep the sand across the top. And to avoid, because pavers are very porous, no matter what manufacturer you get them from, we want to avoid having those polymers driven down into the pores of that concrete. So sweep off the excess sand prior to the first compaction. All that's going to do is help ensure that we're not driving even more polymers into that surface. Because even though the polymers do dry clear, there are other contaminants that might be present on that job. Through the compaction, we might be breaking down some of the sand. The competition says to leave the sand on the surface. Well, if the compaction over the top grinds that right into the surface and breaks down that sand, dusty sand mixed with clear polymers creates a hazy surface, right? So we try to avoid that as best we can. Basic maintenance. We have to get all of the sand off the surface? No, but we're not going to be going over a pile of sand that's 2 inches thick and expect that we're going to get the right compaction or even a clean surface when we're done. So we stick with the traditional means of installation with that, apply the sand, sweep it off, compact it. But this is where it changes, because in the past, manufacturers from Technicell, Alliance, Sable, Marco, SEK, they all recommend 2 to 3 compactions to get that done properly. But Now, we've done one prior to the polymeric sand being put in, a compaction there. We've done another one after the sand has been swept in the first time. If we're at 1/4 of an inch or less from the surface of the paver, if that polymeric sand settles somewhere between the surface and 1/4 of an inch down, we don't need to compact it anymore. And in the past, there was so much airspace in the sand because of the types of sand that they were using that you might drop down 1/2 inch, you might drop down even further, and you'd have to keep going over the top. And that was because of the gradations, or the larger gradations of sand in the mix that would interlock, that would kind of force in between the pavers, but prevent the proper settling of the sand. Well, with the new technologies, we've gone to some finer sands, while still following the ASTM C144 specs for sand gradation for polymeric sands. There's a range that we can run within that level, and that means that we can get into some finer sands that reduce the amount of compaction necessary. So what we find then is if we're at that 1/4 of an inch or higher in the joint, we don't need to compact a second time or even a third time. Simply sweep over the top with one more application of sand, sweep off the surface, and we recommend, and always have, using a leaf blower. The leaf blower has many positive attributes. First of all, making sure that we don't have anything in the pores of the concrete. The other thing is it also helps set the heights of the joints, to even those out. If you're sweeping it and only sweeping it like the competition supposedly recommends, well, then you end up with those marks from the broom, and you get less than a perfect finish because you're brooming in this direction. But what about all the joints that are going this way? It just doesn't line up. It makes sense to use the leaf blower. So we continue on with that process. The competition does recommend using a leaf blower if you talk to them for setting the joint heights. So while it's not recommended to make sure that the sand works, they do recommend it for setting the joints. It only makes sense, and it's one of their misinformation pieces that they put. So now it comes to activation. We've swept it off, we've blown it, set the joints, we've removed any excess material from the surface, sand or otherwise, and we're left with a completely ready to apply joint with it. And that is that 3-step process in 2 minutes. Start with misting, go back and wet it down, a showering of it. You're not going to wash those joints out anymore. You don't want to use a straight sprayer on the hose, but again, at that 2-minute mark, we get the faintest hint of activation of the polymers, and at 5 minutes, we have some significant reaction. We don't want to be moving that sand around after 5 minutes. And I'll show you what I mean right here. This is just a sample, but I'll let you guys pass it around. This was done just before you got here. And I am not making it up. This has some significant set to it. And this is just the sand with water. There's nothing else. I'm not doing a trick. We'll do one right over here. This is a polymeric sand. Nothing's coming off of it. That reaction occurs that is holding everything together. Holding everything together to the point that I'm going to cut off a piece, send it around to you guys. You tell me how that feels. But here is the other point I was trying to make. Now, as he passes that around, we're going to start on this end. Take a piece of it. It's very firm. You'll see over there. And if I take a piece and go like this, it's holding together, but it's significantly lost its strength. Feel how spongy that is. Feel how tight that is. By not touching it, there's a significant difference in the performance of that product. We haven't even gotten to the presentation yet, you guys.
Really?
SRW's Pavermate Z3 is up to joints of 2 inches. Well, you can see here we're doing even more than that, and it sets up very quickly. This has been here for about 20 minutes, but we do this test at 10 minutes, and we'll compare here to what the competition does, and simply dunk them in water. So we say, if it's protected against rain in 10 minutes, that's going to be one of our big things here. How does that really work? Well, once that reaction occurs within our sand, it doesn't continue to absorb moisture. So it's going to repel it. It's not going to swell. It's not going to have any of those issues. And joints up to 2 inches, I'm sure we could go well beyond that, but we had to give it a level, and we had to give the competition something to work up to, right? Okay. Concrete pavers and clay pavers. Clay pavers are one of those things that everybody kind of stays away from. But really what's happening there is concrete has this unique ability to hold moisture. So if we're going to do it, we need to make sure that those clay pavers are completely dry. And if you ever do a clay paver installation, always test it first. Because what's likely to happen is those polymers are going to activate on the surface as that water draws up. They seem very dense, they're extremely hard, but they're also very porous.
If you want to see 500 square feet of white colored red pavers, I can show you that. Not
So-
our choice, by the way. Anyway.
So the real risk there with using it on clay pavers. Now, why we don't go out and advertise it like crazy, this is not on the front of our bag where I put clay pavers. I put that on there last night just to say that we can technically do it. But we have a complete instructions on the back. If you do it, there is a likelihood that you're going to set up some of those polymers on the surface if you're not completely sure that they're dry. We have driveways and walkways, pool decks, patios, false joints. You know, most of the polymeric sands out there can use it for these projects. Most of the sands out there can't go up to joints for 2 inches for a standard polymeric sand. But most importantly, concrete overlay and non-overlay applications. While that's now popular here in Minnesota, down in the southern states, Florida, Georgia, even along the East Coast, for whatever reason, if that concrete, their driveway or walkway is solid, it's just an easier installation for them. So to ensure the success on a concrete overlay, we want to make sure that we're putting weep holes in the concrete. That's simply drilling 3/4 inch holes through it, making sure that wherever the water has a potential to sit on that concrete, you know, if it's 20 or 30 years old, there's going to be a low area where it wants to collect moisture, right? But we have plenty of weep holes there, and always include that 1 inch layer of sand over the top. Because if we don't, the bottom of the pavers and the joints constantly have wet feet and they're constantly sitting in water. And that's not good for them or the polymerics.
So, if you put pavers in one of them, do that. We also
One of the biggest problems that you have with that, if you're not putting that mortar up the edge of the pavers or stone, is that you're creating a channel, an area for water to sit in between that stone, maybe migrate between.
the road is
Sure. Typically what we find in our market and in our weather conditions here is that that's going to last for 5 years or so, and then those joints start breaking apart. Is that what you find? It's just the freeze thaws that we have are brutal for those type of
doing
applications.
something like that. I've done it. It was down there Lake of the Isles, and they put some of that Vermont. Oh, what they call that? Vermont. Called that road. Yep. On that patio, all that water came off that. That was there for a few years, but it didn't, all covered.
I absolutely agree. Even on the East Coast, where that's very common for them to put natural stone over
Vermont
concrete,
green, it's called.
they don't last as long out there either. Now, they may last twice as long as what they do here, but
California or Florida, I think that was also.
we can do it. Yep. So our product, we have 3 primary benefits: zero haze, zero dust, zero problems. To be able to explain that today, we gave you one of the examples right here, just how strong that product is after 10 minutes, 20 minutes. You see what's happening. There's certainly a reaction that occurs. You're touching that sand, and it wasn't sticky. You didn't leave a residue in your hands. But the strength is only going to increase. In 24 hours, this product is phenomenal. The zero haze. Pavermate Z3 does not contain any Portland, fly ash, or crushed limestone. We're going to talk about that and why that's important, which are certainly some of the ingredients in polymeric sands that create hazing. You know, one of the big keywords 10 years ago was, we don't put Portland in our mix. You know, all they did is they changed to fly ash or crushed limestone, which are just as likely to cause hazing, right? But they didn't put Portland in. They said, well, past that, well, they were pretty sneaky. Well, zero dust, especially mixed to bind the polymers to the sand. So we can take our sand right here, and you can play with it to any degree. But if I were to pour some out, we don't have any dust in it. The polymers are all there. We probably have more polymers in the competition. Here's the competition sand. Just a little bit of it. I don't know if you can see it on mine. You can see it closer to the table. I wasn't seeing a whole lot of it. But we're able to lightly bind our polymers. We're able to bind our additives to the sand. So that means when you're sweeping it out, that you're less likely to have hazing on the surface. The polymers do dry clear, but there's much more to that. You know, it's the crushing of the stone or the sand as you're compacting it over the top. There's a lot of things that can create. There we go. That hazing to occur. Zero problems. Rain safe in 10 minutes. Fastest setup on the market in situations with unforeseen weather. Well, what that means is when we say rain safe, and if we're going to advertise it that way, people are going to use it that way and anticipate it. So we better have a big claim against this, right? We better be sure of our actions if we're telling customers that they're rain safe in 10 minutes, because they're going to push it, and they do everywhere. It's not unique to anybody, because every minute that you're not out there, every hour that you're not on a job is costing you money. You only have a certain amount of time in our seasons, so we got to make it happen. And SRW is partnering that to help ensure that you're not going to have these.
You feel good about that? A good job, a good job. Down forward 10 minutes.
Well, here, a downpour in 10 minutes. This is close enough for us right now. This is the same. How's it going to handle it? Not just dropping it in there, but let's leave this for 10 minutes while we're talking. Then I'll take it out and pass it around, and you guys tell me if that's going to hold up. You can hit it with a spray bottle if you want. We can take a section here and just keep spraying it. And I'm being very serious. You can hit it even with the pressure of the water, and this is not going to break it.
This is my job, I have to help.
You can do that, but you have a 1,500 square foot driveway. Pass that around.
So if that product's ready and has been expended, what's your requirements for freezing temperatures? The same where 24 hours above freezing, or is it
That is a great question. Because the competition, everybody is saying, and now SRW says it, he can use his product above 32 degrees, right? As long as your product stays above 32 degrees for the curing time. It's not just during application, but curing. Because if there's moisture in those polymers are very good and they're flexible. But what happens when the water freezes? The water crystallizes, turns rigid, and you have no flexibility in there. It breaks apart the bonding of those polymers. So no matter how good this technology gets, if your water freezes after installation through that curing time, you are going to affect or destroy that polymeric sand. So while we advertise it and we say, yeah, you can use it about 32 degrees, and we try to move on very quickly as everybody else does, the key thing here is if your risk dropping, and my personal thing is 37 degrees. If it says that it's going to get to a low of 37 degrees in the fall, and you want to push it, okay. But if it drops down to that 32 degree mark and the water freezes, you no longer have a cushion, and it's a lot harder to take out partially set polymeric sand in a joint than it is just to weight it. Anybody ever tried to remove polymeric sand?
Yeah.
Anybody hate their job after that?
Can you remind us of what is the current time?
Sure. Curing time is entirely dependent on the environment that you're putting it in. If you're putting it on a 90-degree day, go ahead, put it in on a 90-degree day. It's as soon as that water hits it, that's what activates it. It's only going to dry out that much faster. But the curing time is best determined by touching the joints. In cooler temperatures, so on a 90-degree day, you can come in 24 hours, and that is sufficiently cured that you could drive a Mack truck against those things, and you're not going to destroy the joint. But you do it at 40 degrees, well, you know, it takes that much longer for water to evaporate out of a product when the sun's not hitting it directly. The water just can't come out at those lower temperatures, so it sits there, and it could be flexible. The joints could be touched and physically mobile for 2 or 3 days. It's possible. So there is variabilities there, and it just is based on the conditions in which you're applying. Knowing that those lower temperatures and the dew points are likely to hit every night, you know, moisture's going to collect on the surface, but we want to give it some extra days before we have that freezing. If you do that, you should never have big problems with polymer sand of not setting.
2.70 out.
It would probably take a little longer to dry out to 2.7.
So if it's rain safe, then it accidentally gets taken irrigation. It's still rain safe, but the curing time is rain safe.
So, yes, the only way that we're going to get polymeric sand to cure out is to allow it to dry. If it never has a chance to dry out, then your joints are going to stay flexible, and if people are picking at it and doing those kind of things, they're going to see that could ultimately break down over a while. You saw with that one piece, simply moving it with my finger. If you're walking across it, you know, if your joints are too high and you pick it out,
They're putting furniture on.
if they're putting furniture on. Well, that's one of the biggest problems that they have with those light joint products for natural stone and flagging, right? You put your furniture on too early, and those joints aren't settled. What makes that product so different from any other polymeric sand is that the extreme sand, it has to support itself. If you're doing a joint that's 2 inches wide, let's say a standard joint is a maximum of 3/8 of an inch, right? Most joints are not going to be any wider than 3/8 of an inch. It's an inch to an inch and a half deep, the polymeric sand that's activated. So you have 3 times the thickness than you do width. But on a light joint material, like let's say your stone is only 1.5 inches, and you actually have 1.5 inches, but you're going 4 inches. So that area has to protect itself. It has to be strong enough that it's not going to break apart from heels or the edges of chairs, tables, things like that. So that product is completely different. Compaction is critical for the success of it.
I suppose it would be a good idea to just take on sticker drop.
Yes.
I bet that would be a good thing.
But this sand is more protected than any other polymeric sand that we've had, that we've ever offered, in the fact that it does have that rain safe. If it gets wet through that curing process, all you're doing is extending out the curing process. That can't go on forever, but it can go on for an awful long time. If you go on for 2 weeks, people are saying, hey, it's just not setting up. Well, maybe you should turn off your sprinkler, you know? So it shouldn't be that big. We got the great music. Zero haze. Our polymers, they go into our mixed white. Hit it with water just like you would during activation.
That's nice, huh?
What's that?
That's the light.
Pass it around. Leave the As you're passing that around, that is the polymers of our mix. If your fingers are wet, you're gonna notice that that will get a little bit sticky. But there's nothing more in it. That's the polymers that we use. You can see right here, putting it over the top of the paper, how clear that truly is. There's no magic that's happening with these polymers. They look white when they go in. If you see your polymeric sand and you see white on your hand, they dry people. Polymeric sand contaminants. Now this is where we talk about that Portland, that fly ash, that crushed limestone. And these are all products that are necessary for polymeric sands for one reason and one reason alone. What do you think it is? Anybody? Look, you know, that's probably not a bad idea. It's put in there for people associated it with adhesive or strength, right? Not true at all. It is a cheap way to increase the pH. Those polymers right there, if you want them to cure out, and what we mean by curing out is once they activate with water, we don't want them to continue absorbing water. So after they've activated, we want them to dry out and stay strong. Just a little bit of powder created a film, a sheet this strong overnight. So they have the Portland, they have the crushed limestone, they have the fly ash. All of these products have an inherently high pH between 11 and 13. So it's an opposite of an acid. And by having that high pH, it simply allows those polymers to not continue to absorb any additional moisture. So after that first activation, remember I told you if somebody sweeps in the sand and leaves it for a week, it's going to absorb moisture. That reaction has occurred and it won't continue to absorb moisture after that. It'll stay that nice, shiny, or soft sand that you never set up. It's because companies are putting these in. Now, this is necessary for the strength and integrity because what would happen every time it rained? Those strong polymers would weaken and absorb moisture again. It would get sticky. It would have these things. So we need to have something in the polymeric sand to prevent that from happening. SRW went to a much better product that simply isn't clear. We still have to increase the pH, but we're not using any of these materials right here. And that's where talking to chemists has really helped me out quite a bit. But that comes at an expense. And I'm telling you about how great this product is. But we haven't even talked about the cost of it. I believe that we're offering the best polymeric sand on the market, not because it's haze-free or dust-free, or that it's rain-safe in 10 minutes, but because we can offer all these things that the competition can't, and we can do it at a better price. And how do we do that? Alliance, we've used that before. Where is that made? It's made in Toronto, Canada. They only have one operation that manufactures their sand. So they ship all around the country. And when you ship sand around the country, I think it's really expensive. Trusting on there, I do quite a bit of shipping of it. But we have 6 different manufacturers here in 2018 to manufacture our sand. So the sand that's made for our market here is used to be made in St. Paul. It's now made in Missouri, Kansas City, just because it was a better point to get the raw material. So we're closer to the source, and we only had to ship it one time versus shipping it from the source to the manufacturer and then back again to us. So it was a true cost savings as manufacturing. When we can save literally dollars per bag by having it manufactured around the country, and all I have to do is create the admix, approve those sands, and simply have it made where they do it best. They specialize in this. We can get you the highest quality sand at a better price than what the competition can offer. Is there any other questions in regard to the contaminants that might be in polymeric sand? This is what a pallet of our sand looks like. There's 49 to a pallet, 49 bags, so 7 layers and 7. These bags are not entirely waterproof. Alliance says that their bags are waterproof. They're heat sealed on the top and the bottom. They do a good job. But what we've done to try to protect our products, either buying by the pallet or the distributor is buying by the pallet like Hedberg, we put a plastic sheet over the top of the pallet itself before any product was on there. We put a piece of cardboard over the top of that so that the bags don't settle in between the slats of the pallet. And We don't pierce them and put a fork through it. We load the product up. We then put a 6 millimeter, the same thickness as our bag. It's a very thick bag. A pallet cover over the entire pallet. It is a bag that goes over the entire pallet. Wrap it up with stretch film that is 2 to 3 times the amount of what the competition does, and our products can be stored outside even though we have an opening in our bags. We have an opening, we don't have a heat sealed bag because we manufacture it in 6 locations. We don't have one. A $300,000 piece of equipment to heat seal it, and we did that times 6. We wouldn't be able to afford to make sand. So we still have to stick with a valve bag, and common practice is to try to keep these dry or under cover until we want to use them. Okay, so this is just kind of one of those filler sheets that we have in our PowerPoint. But the idea here is not everybody is going to have a rubber plated compactor. Even though you may want one, you know, I want one too, and that's a compactor we have at work. And we sell polymeric sand, and I still don't have a rubber plated compactor. And the reason is because those darn things are $250, and they're so difficult to put on because you don't want to use them for every application. So if somebody does happen to have them, they're in the back of the truck. One really easy thing to do is when you're installing pavers, oftentimes you'll have a piece of woven. Maybe you did that during the install as you excavated out the area before you put base material in, you put some 200-pound woven in. Use an extra piece of that, run over the top. You're going to avoid any of those scratches that happen from that metal plate over the top of the paver.
With a big piece of cardboard work, you ever tried that?
If you use a tight Berber carpet, that works too. But again, it does take away some of the compaction, so it depends on the size compactor you're using. People say, hey, I use a piece of carpet, it worked great. Yes, it does work. There's a little bit of drawback, and I would not recommend that for the initial setting for the heights of the pavers. But cardboard, if you can get it to stay on, by the way, I use clamps to hold on a piece of carpet. I could not keep it on.
Get a big piece and throw it down on a job and put it on.
It's possible. It is going to break up, and you're going to get residue from the cardboard, but it is possible. More of the same music, but
throw that in the mixer, go take a coffee break and put some water in there, I guess you can have coffee.
So all I'm doing right here is activating a couple of samples. Never spray it with the nozzle open like I did. Create a new one. And we're doing this with the competition too. The same activation. All we're trying to do is get enough water through that sample to make sure we activate it from the top to the bottom and keep everything equal. And we'll go through this in a little bit. Is there any questions? I've been talking a lot. We haven't talked.
Joel, do you have problems with your stuff like before when it first came out, everybody would cut the bags and start at one end of the patio and sweep the other, and then they'd have failures because polymers were lighter and the sand was heavier? Do we still have that problem? Is it better to try to fill the joints and sweep as little as possible with the new products?
Well, it's always best to try to fill the joints. But I've done my fair share of jobs. Many of you guys have, I mean, but that doesn't make sense. I'm holding a 50-pound bag trying to fill it. It doesn't make sense to do it. But we do want to minimize the distance that that sand has to travel because there's two ingredients in there. There's polymers, which are powder, right? And there's sand. And what happens when you start sweeping those two? The powders, even though they're lighter, they want to drop to the bottom. The larger particles, the sand, comes to the top. And so the polymers come out of that sand first, and then you keep sweeping the sand. So if you're sweeping 20 feet away, at the end of that 20 feet, that sand is going to be weaker than the sand when you first started that area. Because the sand is going to keep migrating up, polymers will not. Now we've been able to rectify that situation to a great degree by lightly bonding those polymers to the sand. But as abrasive as that material is, there's only so much that we can do. So if you're going to put a big pile down in one area and sweep it across this entire patio that we've created here, not a good idea. A good practice, take your knife, slice the bottom of the bag, minimize the amount of handling that you have to do with the bag, and drag it across. By the time you get 20, 30 feet, that bag is empty. Sweep 3 or 4 feet on each side. That should be enough sand to do that. And then you're also minimizing the amount of back pain. I've had 2 back surgeries myself, I gotta tell you. Try to avoid that if you can. What makes our sand the best even before it's mixed with the polymers? It really has to do with the type of sand. And not just digging the sand out of the ground, you can see with our colors, some of you have the tan. We'll put it right here. This is a very common sand here in the Midwest, all the way from Kansas up here into Minnesota. It's the same gradation or color. Here's the black and tan. So these are very refined sands. And in some cases, they're manufactured sand. The black, for example, anybody ever do any sandblasting? Black diamond? You ever heard of it? You know what that product is? No, it's actually the residue of a coal-burning power plant. It's coal slag. So it's the solids, it's the silica that's generated as they're burning that coal, and that ends up in the bottom of the burning. They must have a big burning barrel to do that, right? I'm not sure. But anyway, they clean that out. And while there's, we had the concern, well, is there any heavy metals in there? Is there any other issues that this might contaminate? And really, no, there's not. This product can be used in a multitude of different applications, and we don't have any issues with that. So it is coal slag that makes the black. The ivory, sometimes it's marble out on the East Coast. Here, it's a silica that we make that ivory out of, but a very pure product. So it's with the sand that we use. So we take this, we refine it if necessary to clean up those colors, pull out any metals that may be naturally in there that create dark particles for the light sand. We wash it. It then goes through an open flame dryer. And then the final step is to go through a grater or a screen that pulls off the fines, sets the heights for the top and the bottom, and we're left with that range of a very consistent sand. Once our admix is blended, we're the cleanest sand available on the market by washing it, drying it, and screening it. You have the industry leader in performance and quality. That's the Z3 sand, the zero haze, zero dust, zero problems. And at the best price. We talked about that. And what does it really boil down to? It's shipping. We're making a better quality product with better polymers, the better admix, reactive technology at a better price. This has been sitting in here at least 10 minutes, right? Sorry to get you wet here, but we're going to pass that around. That's the integrity of that sand. Yep, test the center. Do you see any noticeable difference? Is it absorbing the moisture? What is respirable crystalline silica? Have we heard this recently? OSHA's coming out, they're talking about making sure that we're protecting our workers, making sure that people that are out there breathing the dust from cutting with a diamond saw to any number of things, that we're doing the best that we can as owners of companies to make sure that our workers are protected. Well, how does that apply towards polymeric sand? Because technically sand, it's a silica, right? For the most part. Even the pole slag, primarily silica. So how does that relate to polymeric sand? You have companies out there like Alliance, SEK, that are advertising that their products are RCS safe. Is that entirely true? I did the research on it because I couldn't find anything as a manufacturer that I could do that would give you the confidence that our products were safe to use. Even though ours is cleaner than the competition's, we wash it first. That takes out a lot of the fume, the finest of powders that are generated by sands. And then we dry it and screen it. We're taking out any residual that may remain. But how can I tell you with confidence that it's RCS safe? You know what the competition is doing is the same thing that they recommend for you to do as a contractor. They're dumping their sand out, so they say it's sweeping it while they have this little box under their shirt. It's drawing in the air as they're sweeping, assuming that this is an average installation. It could have been doing it inside a heated warehouse. It could have been doing it on a windy day. All these things affect how that test performs, right? Or they could have done it 10 times. And one of those tests they actually passed. What does that mean for you? I think it's misleading to the market that says they're doing the same test that you would do on a job, and in their conditions it passed. If there is ever a test for a manufacturer that accurately tells you that you've been able to clean it up and make sure that it meets all those guidelines, we're going to do those tests. But to do the same tests that you would do, we'd rather show you that our product, compared to any other dustless formula, is better. We saw where we're putting it in the mixer, how much dust was being generated there. If you compare it to Alliance, for example, their rapid set technology or their new G2 that was produced in 2018, that was their product in that video. That was their dustless formula. It wasn't so good on the right-hand side of the screen, was it? And they're the ones telling you that their product was RCS safe. And it could entirely be under most conditions. But we have not done those tests because I think it's a disservice to just do the same test that you would do on a job site. In the fact that, of course, it's going to tell you it works. It works under the conditions in which we apply. So that's my spiel on it. I am very confident that our product is better with respect to potential for RCS contaminants on the job site because of what we do, binding the polymer, reducing the dust in the sand even before we blend it. But putting a compactor over the top of it, leaving the potential to crush the stone that I'm not in control of on the job site, I can't tell you with confidence if you would ever have that, ever a situation where it would occur. I'm like a ninja. for you guys, any videos that you may see online at srwproducts.com is going to contain me and my belly, because that's all we typically see. This is a competition sand that's been sitting there over 10 minutes. You can care to guess what's going to happen to their sand? What's the difference with 10-minute protection? Well, it's still together here, right? Anybody care to feel it? Let's let it sit in there just for a minute and see what happens. That's what makes the difference with that reactive technology. That's what sets us apart. In that, yes, it is protected against rain and unforecasted events, but that reaction helps to ensure that those polymers will never go anywhere. If it rains through the curing process, we don't have to worry about the polymers washing out. They've already been set. They're not going anywhere. So, under normal conditions, you get a ridiculously strong sand. Everybody's seen this one, right? This was done last week. Nothing special about it. Here, the competition liked our product so much. They produced, let's just tell you, it's the Alliance G2, right? They came out with that in 2018. That was their no-dust formula. There was nothing better on the market. In 2018, we also came out with the Z3. Their chemist came up to our salesman and said, SRW has a better product in 2018 than what they did. You know why they said that? Because in 2019, they were coming up with rapid set technology. Here's rapid set technology. Looks fine. This is a week old as well. Any observation about that puck right there? Here, why don't you directly compare it to ours? Both were done in the same manner. Did it shrink or did it swell over the top? Did you see how much swelling occurred here? They were both done in the same manner. Let's not give it a disadvantage. Let's pick up the pieces here. There's no integrity there. And then we swish it around. The polymers discolor the water. That's a traditional polymeric sand. This is not SRW. Rain safe in 10 minutes. We've been able to show that with the videos we've talked about. Does anybody have any questions on those? 2017, that's correct that we have. You know what really caused me to change? What happened is our recipe was good for what the polymeric sands were on the market. It was a good polymeric sand. The problem is that the manufacturer of the polymers decided to create one of their products. Their supplier for one of the monomers for the product that they created for us had a force majeure. They had a fire. They had something that was an active god that they couldn't control. So they decided to start making that product internally, the raw material. They changed it, and there started to be problems with the potential for hazing. They didn't clean it just right. Well, all of a sudden we had a good product that turned to crap immediately. I mean, in 1 year, we went from a decent selling product and a decent portion of our market to nothing. You can't have that. So now, we've been able to eliminate all of that. Completely new technologies, new polymers, a new company that isn't going to make those changes on us. And just so you know, our business went from 100 truckloads a year. Seems like a lot, right? But in the nationwide, that 100 truckloads is nothing. You know, some of the competition, they have companies that are doing 400 truckloads. So we're relatively small in the market. But we doubled our business in 1 year. In 1 year, we've doubled the amount of business that we have. In this year, we're going to double it again. We've increased in 2 years 4 times the size. It's become a significant portion of our business. We rely on this. We can't afford for it to go bad. We can't afford to have negative experiences by the customer. We had to ensure that none of that was going to happen when we went. And the competition is really running scared. You know, when they start having meetings with the owner of your company, competition, that's got to be kind of interesting, huh? I'd love to be a fly on the wall for that. ASTM 144 gradation. You know, honestly, what this is, it's a masonry spec. But companies are advertising, Cut and Seal, Alliance are advertising that their products are ASTM C144. I don't know what the big deal is here, because if you take a look at ICPI, the original intent of that is when pavers were Holland pavers, and they were very tight joints. ASTM C144 was great because some of the larger particles in there would actually spread those pavers apart. They would force them down in there, and they would create that interlocking that was necessary for traditional paver installation before polymer mixing. They kept on with that spec because it was just convenient. There was nobody out there to tell them that it was or wasn't necessary. But what about the pavers we have now? How wide are the joints? Do we truly get an interlocking paver system anymore when the joints are 3/8 of an inch? Well, we've got those little ears that are sticking out at the bottom and kind of technically touching each other. But those joints have certainly gotten wider. So the polymeric sander, the ASTM spec, no longer applies because those larger pieces aren't doing the job that they're intended to do. If we really wanted to follow the intent of ICPI, in some of these cases with those 3/8 inch joints, we'd be using 1/4 inch rock in addition to the sand to get that interlocking that's necessary. But you're not going to find somebody out there that manufactures it. So what we have here, what replaces that interlocking nature of a traditional sand that would go into jointing sand, a mason sand that would go into joint? We have polymers in it, right, that provide that interlocking nature, that lock everything together and prevent mobility or motion. So while we still do follow this gradation, companies that are advertising, it really means nothing. How does Pavermate and Z2 compare to the polymeric sands in the market? We've really gone through this through the entire operation, or through the presentation. On that sample that you have there, their technologies and reactive technologies are not at the levels that we have. We find that when we activate their samples in the same manner that we do with ours, it does hold together better than the sample you saw here. It doesn't activate at the bottom. We're only talking half an inch depth there, and it doesn't activate on the bottom. It stays sand. So you get a nice skin on the surface that's probably just less than 1/4 of an inch. That's setting up. Technoseal's Next-Gel, a very good product. They have nothing to complain. They're a very stand-up company, but they do have some swelling issues with their product as well if you over-apply the moisture. Alliance has the over-application of moisture, the swelling that happens. Ours is not experiencing that. The nature of the polymers we use will not happen. There are very stand-up companies out there. Technoseal is one of them. I have nothing to complain about. They have a great management staff and a great product. Competitive instructions: compact with sand over the pavers, no blowing, activate with 1 watering. Well, we already talked about that. We talked how those are misinformations that they're telling you. What they're not telling you: overloading the pores with the fines, increasing the chance of hazing, and activating just over half the area is what Z3 is. They do 30 seconds, 30 square feet in 30 seconds. We're doing 200 square feet in 2 minutes, calculate it out. They're doing 120, we're doing 200. Competitive sand, swelling of the joints during activation. 2 of the leading producers can experience this with over-application of water. Proper cleaning is critical, as sand setting on the surface is very difficult, if not impossible, to remove. There are companies out there that their polymers are amazing. They're amazingly strong. But if you don't clean that perfectly, and you get it on the surface of the pavers, they're all but impossible to remove too. So we have to have a product that's going to work for you, right? Marketing with misinformation, we've already talked about that. What happens if all goes wrong? It rains during the install. Now, we've already addressed it rains after you put it down, right? We don't have to worry about those polymers washing out of the joints. What happens when you're sweeping it over the top and it rains? Oh, we didn't talk about that, right? Is my sand protected against that? No. Nope, it's not. Basic prep is not followed. The use of a compactor or a leaf blower. We're not cleaning that surface off properly before we activate the sand. We leave the potential to load those pores up on the concrete or the pavers and create some residue from the sand and polymers mixing. Didn't activate the sand for multiple days after sweeping into the joints. You guys brought that up. Thank you for that, by the way. I had like a little magic person back here typing that in for me. And this really happens. You guys talked about it, you know? It's not recommended. This old house, they did it. It's the information that they're putting out to a mass of amount of people. You know, that's not recommended. Clean the bags on the side of the house prior to use and the sand gets wet, what happens? Well, that activation occurs. We want to make sure that we're offering the basic steps to try to protect that sand prior to application. But what about the first couple of ones here? We do leave the potential for hazing if it is installed improperly. So, in the past, we recommend using an acid, right? What would you use to clean it up?
Super hot water and scrub brush and good luck.
Ruined it for me. You know what? But that's honestly true, and you don't.
I've been there, done that.
But you don't necessarily need the surfactants or the soap involved there. But it is a heated pressure washer. The steam, the hot water, temperatures of around 190 degrees. All that does is soften the polymers. Why is this different than old polymeric sands from the past, the ones that use Portland, or the competition that still uses fly ash and crushed limestone? Is because fly ash and Portland still have the ability to bond to the surface of that concrete. They can physically bond if it gets there and it hazes. This product cannot. So all we have to do is remove a polymer. If it's really bad and you don't want to rent a heated pressure washer because it's $150 and you don't want to make that expense, well, you could go and get a sealer strip or two and just use a regular pressure washer. The chemical breakdown of those polymers will work as well. It's a little bit give and take there because that only does 200 square feet. I'm guessing a gallon of that product is going to run you about 55 to 60 bucks. So oftentimes it is better if everything does go wrong. Try a heated pressure washer first.
Let's say that you got all the papers set, and pretty much it starts raining. And then you go out, come back the next day, rain for 3-4 hours, come back the next day and the pavers are still wet, obviously. So what, would you do the sand then? You wait, try to see if you got 2, 3, or 4 dry days, and then do the sand. Is that, I guess that's what I would do, but what we do.
You know,
Say that for a reason.
sometimes that works and sometimes it doesn't. It depends on how saturated that concrete is. Because while you're drying off the surface, you put polymeric sand, those polymers are hygroscopic. They are searching for water. That means that they can pull that moisture out of the concrete with their sufficient quantities in there. So it may work 3 times out of 4, but there will be a time that it doesn't. They're too saturated. So be aware of that. I would always recommend waiting. If those papers are wet, physically enhanced, darkened by the water, don't even consider it. Not that day. Not that day.
Smoke, you get 3, 4, 5 days, dry, sunny days on it, and then I can put that with.
And I don't know that that's necessarily, whether that's necessary or not to wait that long. But you do need a level of time to get those papers sufficiently dry, so it's not waking up that moisture out of the Do you have any other questions regarding the extreme sand? Because we did talk about it a number of times. The biggest thing that I do want you to remember is the compaction. Compaction. That is necessary to that. This technology here is not that no haze, no problem, no dust formula. This is going to be dusty. Because the active ingredient in the slate right here is a 1/4 inch minus crushed bluestone. It's 1/4 inch minus, it's got a lot of fines in it. That's what makes this different. But that makes this a real benefit for wide joints because it compacts into those joints even before activation. And that's really critical for the success of your wide joint experience. Now we have tested this product to go over 8 inches at a depth of 1.5 inches. 8 inches. We only advertise 4. So if you need to push it a little bit, as long as you get proper compaction and activation of water, never got a chance of working.
So this is probably good for that kind of 5/8. That would be a real good product to use it.
You got a 5/8 joint with natural stone? Yes, absolutely. And by the way, just because of the color, the slate is the most common color. It's sold 3 to 1. So, TAM, it works just as well. It is a cleaner material, but there's a significant amount of polymers in this mix. You just have to make sure you're cleaning And the reason why we made this product for natural stone, they tend to be a little bit more dense, they clean off a lot easier when you're prepping it before you activate it with water. If you were to use this recipe on pavers, what do you think would happen? Those fines would load the surface of the pores on that concrete. It's not recommended. You can see here, joints up to 4 inches, natural stone, wet cast, very tight surface. Patios, walkways, it never says anything about pavers. Don't put it on pavers.
So these have smaller, this is still a better product for any natural stone, same
Yes.
price.
Correct. We're not gonna go through this video. This is long and boring, and actually we've come to our time. And I didn't get to talk about any other product besides polymeric sand. It is disappointing. Do you guys have any other questions? I know I talk too much. That's what my wife says. So you're gonna have to believe it. But do you have any other questions in reference to any products? If you want to talk about cleaners and sealers and the right way to apply those to over the top of polymeric sands, that is one thing we didn't talk about, so let's do it right now. The sand typically, under normal conditions, in any given week, we should find that that's basically cured. Cured is a funny term. Hardened to the point that you can do anything that you want. But typically 24 to 48 hours, you're going to find that you can drive across it, you can put your furniture back on and not have any issue. In wet conditions, it changes a little bit. But that's the same with regular polymeric sand. You just have to let those harden. And we tell that by the strength of the joint. When it comes to cleaning and sealing, completely different cured weight. And we recommend waiting 28 days. The reason is there still is some strength, as that water slowly purges out of the system. Because the polymers like to absorb moisture, and a lot of the chemicals in sealers and cleaners, they could be solvents, they could be whatever. Oil and water don't like to mix, they kind of mess things up on the surface of those joints. So we recommend waiting 28 days. That way, we've been able to purge all the moisture out of the system in almost every case. Those joints are sufficiently hard, they're not reacting any longer, they don't have any excess moisture in them, and we can go ahead and clean them with acid, we can seal them with a solvent-based, water-based, it does not matter. If you really need to push it, and you're interested in putting a penetrating sealer over the top, wait at least 2 weeks. But cleaning specifically those acids, we want to wait 28